The universe we live in is huge, maybe even infinite. There are hundreds of billions of galaxies, each with hundreds of billions of stars, and most of these star systems have planets orbiting them, many of which are habitable. New exoplanets are being discovered every day, and with all of this data that shows so many places for life to exist outside of our solar system, it's hard not to ask the question, where is all the life in the universe? This is known as the Fermi paradox, and it's been puzzling people for decades. And as long as it's been puzzling people, people have been looking for life on other worlds. Determined to find other life in the universe and to systemize aspects of the search, Russian astrophysicist Nikolai Kardashev proposed a civilization scale in 1964, which later took his name. He created the scale in order to gain a better understanding of what to look for when combing the stars for alien civilizations. In this video, we will look at each level of the scale and what kind of technological milestones must be met for each. This channel will essentially focus on the steps that humanity needs to take in order to progress on the scale. Welcome to our orbital future. The Kardashev scale is both simple and nuanced and consists of both qualitative and quantitative components. The qualitative component classifies a civilization based on its cosmic scale, planetary, stellar, and galactic. The quantitative component of the original scale is a bit more complex and has to do with the amount of energy the civilization is able to harness in units of watts. In the years since it was proposed, the scale has been modified and adjusted by many prominent physicists such as Carl Sagan and Michio Kaku, in some ways simplifying the scale. And to add a layer of simplicity, we can also classify in terms of the civilization's population. A K1 civilization has the technological ability to harness nearly all the energy from the star hitting the host planet. The sun hits Earth with nearly 10 to the 17 watts of energy at any given moment. A K1 civilization's energy capacity would be around 10 to the 16 watts of energy. And to further simplify, we can approximate the population of a K1 civilization to be around 10 to the 10 or 10 billion people. This distributes the energy capacity to about a megawatt per person. Obviously, energy is not distributed uniformly, and while a lot of it will go directly to civilians, a large portion will be dedicated to large civilization-scale projects. So this number helps us generalize to get a better sense of scale. At this point, the civilization has certainly had a presence in space for quite a while, and may even be constructing or already have constructed large megastructures in the orbital space around its host planet. A K2 civilization is able to harness nearly all the energy from the host star's total output. Its total power capacity would be somewhere in the ballpark of 10 to the 26 watts, and the approximate size of the population would be around 10 to the 20 people, or 100 billion. So a K2 civilization's population would be comprised of the equivalent of 10 billion K1 civilizations. That's a K1 civilization of K1 civilizations. The total energy output from our own sun is about 3.8 times 10 to the 26 watts. Harnessing the majority of the energy output from the sun is a great task and not impossible. Probably the most efficient way to do this is with a Dyson sphere. Dyson spheres are huge megastructures built around a star with the intention of capturing its energy for use and beaming it across the solar system to be used in various locations of a civilization. Dyson structures can take many forms, including the original concept, the Dyson shell, a slightly more practical option, the Dyson rings, and the third most efficient and practical form is the Dyson swarm, consisting of many millions of small spacecraft designed to soak up the star's energy like a solar panel and beam it back to the civilization for use in the form of microwaves. I could go on for a while about Dyson structures, so it will be a topic for a future video. For now, let's move on to K3 civilizations. A K3 civilization would be able to harness nearly all the total energy from the stars in its galaxy. At this rate, the energy capacity for the civilization would be near 10 to the 36 watts, an incomprehensibly large amount primarily used to power interstellar spacecraft and the infrastructure required to constantly expand its reach throughout the galaxy. The population estimate for a K3 civilization is about 10 to the 30, though at this point I think it's important we be realistic about a few things. Population likely will not grow in linear proportion to energy capacity. Throughout history, as the global population has grown, energy capacity has increased at a more rapid pace. This is logical, giving an exponentially more advanced civilization's citizens a larger portion of power relative to previous civilization levels. So I anticipate a hypothetical K3 civilization would have much fewer than 10 to the 30 people, though it would likely range somewhere in or near that order of magnitude. The second thing to be realistic about is the fact that most galaxies tend to be in the area of many hundreds of light years across. So unless a form of faster than light travel emerges before the galaxy is conquered, it's hard to say if its entirety would be colonized at all. Most civilizations on the brink of K3 status would be moving between star systems on generation ships moving at roughly 10 to 20% of light speed, meaning it would take millions of years just to span the galaxy's diameter, let alone colonize its entire volume. Additionally, communication can't travel faster than light either, which makes organized effort incredibly difficult, increasing the chance of catastrophe before the galaxy has been conquered entirely. So realistically, when we talk about K3 civilizations, we are referring to multistellar civilizations that have colonies on a large number of stars, with the intention of continuing until they have reached an adequate amount of resources to maintain control over the galaxy as a whole. There is one scenario I could see that would allow for a total galactic empire. This would come from two or more civilizations emerging in the same galaxy, encountering each other, deciding not to destroy each other, and instead forming a galactic allegiance, spreading their dominion to every star system. We don't know what the probability of intelligent life forming in any given galaxy is, let alone the probability that it evolves to K3 status, but it seems unlikely that two or more would emerge in the same galaxy at the same time and both make it to K2 plus status before discovering one another. So this scenario isn't one that seems entirely likely, but not impossible in the incredibly large number of galaxies in the cosmos. While the original scale proposed by Kardashev in the 1960s only contains these three levels, in the years since then, many have proposed additional levels.
With extra steps.
Continuing logically along the same path, a hypothetical K4 civilization would possess the technological prowess to harness and use the energy from multiple galaxies or even all the galaxies in the universe. At this point, the civilization's population is approaching somewhere on the order of magnitude of 1,000 trillion, the equivalent of a K3 civilization of K1 civilizations. A civilization with intergalactic reach almost certainly would have access to technology beyond our current understanding. Perhaps they have found a method of transporting cargo and humans faster than light by surfing gravitational waves across spacetime, or even using intergalactic portals like wormholes, allowing them to cut down the distance between galactic colonies. Or maybe they have found a way to extend human life and/or human consciousness indefinitely, making the multi-million-year journey between galaxies only a small portion of their infinite lifespans, and therefore much more bearable relatively. Physicist Michio Kaku has proposed classifying a K4 civilization by its ability to harness galactic energy sources such as dark matter and dark energy. A proposed K5 civilization would have colonized every galaxy in the known universe and then proceed to begin conquering every galaxy in every other known universe. A multiversal colonization effort would probably span hundreds of billions of years and would see an innumerable population. The only level existing beyond K5 would be an omnipotent being or civilization, also referred to as a K6 or Omega-type civilization. They would be able to see and interact with everything going on in every universe with the ease of switching between browser tabs. Continuing this train of thought encounters high-level conversations of belief, spirituality, afterlife, simulation theory, and more. These won't be topics of discussion on this channel, as it is much more focused on Earth and the technological advancements that are required and being worked on in order to progress humanity further along the Kardashev Scale. You may have noticed that our human civilization here on Earth does not particularly fit well into any category, and that's correct. Currently, Earth has not yet reached K1 status. However, we are further along than a K0 civilization, which has a very small population, likely non-unified, and very technologically limited. Let's return to the metrics of a K1 civilization to determine where Earth stands. A K1 civilization is able to harness nearly all the energy supplied to its host planet by its star. In Earth's case, somewhere between 10 to the 16 and 10 to the 17 watts, and the population would be in the tens of billions. Our current population is 8 billion, and it's projected to reach 10 billion sometime around the 2060s. Our global civilization consumes over 14 million tons of oil equivalent annually, which is around 19 terawatts. Compared to our goal of 10 petawatts, it is a measly 1,000th of the way there. But when we remember that relative to population, energy capacity has increased exponentially throughout history and will likely continue to do so, the numbers make a little more sense. 13 is about 3/4 of 17, and 8 billion is 80% of 10 billion, which seems to line up nicely with Earth's commonly accepted Kardashev status of K0.75. While it's definitely disappointing to learn that we have not even reached the first tier of this scale, it's important to remember that if we really want to be a K1 civilization, we have to act like just that, a civilization, a global cooperative working toward a common goal, the preservation and expansion of humanity into the cosmos. We could become a K1 civilization by the end of this century with no crazy new technology. We can make it happen with technology we already have or are developing today. And we need to work together. Competition can be good to a point, but it can be destructive if we aren't careful. On this channel, we will discuss various strategies we can employ to progress towards K1 status, with an emphasis on building an orbital infrastructure as a foundation for the next industrial revolution, which will happen in space. This will allow us to build space stations much larger than the ones we see today, and with gravity too. These are critical for scientific and technological research in order to progress rapidly. They will also be used as space hotels. As access to space becomes cheaper, space tourism will boom, providing capital to industrial space corporations to fund other space construction projects. This will include more research and development stations, additional space hotels, asteroid mining projects to source materials for larger megastructures like cylindrical habitats, and ultimately planetary excavation of Mercury to build a Dyson structure around the Sun and have near limitless energy capacity. Enough energy to potentially launch an interstellar mission if we so choose. It may seem far out, but it could actually be closer than it seems. But what do you think? Will humanity ascend to the stars and climb the Kardashev ladder, or should we first focus on improving life on Earth? Let us know in the comments below. If you enjoyed this video, hit the like button and consider subscribing so you don't miss the new videos we publish every week dedicated to building humanity's future in space. For now, check out some of our other videos and we'll see you in the next one.